So, good morning, everybody. Today we have to take up another chapter in mathematical physics, and that is Fourier series. Okay, and what is Fourier series? In Fourier series, you will have a function fx, and that function is to be written in the form of sine and cosine functions. Okay, so in Fourier series, we have to write the function in the form of sine and cosine functions. So what is the advantage of this? What is the advantage of writing a function in the form of sine and cosine? All of the harmonics, all of the harmonics can be immediately seen when we write the function in the form of sine and cosine. So जब हम फुरियर सीरीज को साइन एंड कोसाइन फंक्शन के फॉर्म में लिखेंगे, when we will write it in the form of sine and cosine, so all of the harmonics of the function fx can be seen. That is the advantage of writing the Fourier series. And also, so let us write quickly the applications. So it is analysis tool. That means it is used to analyze the function. It can be used to solve partial differential equation. अगर आपको याद आ रहा हो तो I have used many times this Fourier series in solution of partial differential equation. So analysis tool का example हो सकता है to analyze a signal, okay, and also to study harmonics, to study different harmonics. That means suppose some omega naught frequency is there. So how many frequencies are present? For example, omega naught, 2 omega naught. These are known as harmonics. 3 omega naught. All these can be studied in this Fourier series. Okay? All this can be studied once we write the function in the form of a Fourier series. So there will be actually two type of. I will divide the whole chapter in two parts, and the first part will be the full series and the second part will be the half series. So in Fourier series we will have a full series and then half series. So quickly let me discuss what is meaning of full series and what is meaning of half series. So the meaning of full series is, so suppose I discuss the Fourier full series. Okay, so Fourier series can written for a periodic function. The function should be a periodic function, or it should be piecewise periodic. Piecewise periodic. Okay, so the function should be a periodic function. The Fourier series can only be written when the function is periodic function or it is a piecewise periodic. That means you are given that the function is periodic in certain domain, although the very nature of the function may not be periodic, but you are given that the function is periodic in certain domain. So ये मैं आपको बताऊंगा when we will do questions. But in only two cases we can write the Fourier series. And I must tell you the combination of three chapters which now I am going to teach: Fourier series, Laplace transform, and Fourier transform. It gives you sometimes three questions, minimum two questions. Okay, so that's why these three chapters are very important. So, how to write the Fourier series for a function? So, suppose it is a full series, and suppose the period is given between minus pi to pi. Suppose this is the period that is given to us. Okay. So fx is equal to fx, the function is equal to, we will write it like this: a naught by 2. This will be the first term, and plus a1 cos x plus a2 cos 2x. I told you that it is written in the form of harmonics of cosine and sine function, and plus a3 cos 3x plus dash 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 plus b1 sin x plus b2 sin 2x plus dash dash dash. Okay, so this is the Fourier series. You have a function fx, and you have written this function in the form of sine and cosine, all possible harmonics, because you are considering cos x, cos 2x, cos 3x, then sin x, sin 2x, sin 3x. And the first term we take a naught by 2, or we may take a naught also. A naught by 2 simplicity के लिए लेते हैं, I will tell you in some time. So compact form में कैसे लिखेंगे? In compact form, fx will be equal to summation n is equal to 0 to infinity, and the first term will be written, the first term will be written here, a naught plus a naught by 2 plus summation n is equal to 1 to infinity an cos nx plus bn sin nx. So this is the most general form of the Fourier series that we use. This one is the most general form of the Fourier series that we use. Fx is equal to a naught by 2 plus summation n is equal to 1 to infinity an cos nx plus bn sin nx. And there is another form also. Sometimes people write it like this, that fx is equal to, they don't take this by 2, they write summation n is equal to 0 to infinity an cos nx plus bn sin nx. So this is also a Fourier series, and in this first term will be a naught. Okay, so please remember that the Fourier series is a unique series. So here we will get a naught plus a1 cos x plus dash 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 plus b1 sin x plus dash dash dash. So this will also give you a Fourier series, and the first term of this will be equal to the first term of this. So here the value of a naught by 2 and here the value of a naught both will be equal because that is the first term of the Fourier series. And this term is also known as DC term. This term is also known as DC term. Why? Because suppose this x is equal to omega t. Suppose ये some time का function हो and x is equal to some omega t. So this is free from any time. So अगर suppose fx कोई signal हो, suppose fx is some signal or fx is some current. So this series is free from that time variation. So that's why this is called DC term by the analogy of the direct current. Correct? Now if we can write the values of a naught, an and bn, अगर वो हम लिख सकें तो हमारी फूरियर सीरीज बन गई. बिकॉज क्या होगा, एक रेंज की दी जाएगी, a range will be given and a function will be given. So range is given, function is given, we can write Fourier series. We have written. Now what are the unknowns? A naught, an and bn. So if we can calculate a naught, an and bn, then our job is done. So up to this, any confusion? Anybody wants to ask anything? No confusion. Huh? So let me quickly now write the coefficient. So let me quickly write the coefficients of the, and suppose मैं Fourier series ये वाली लेता हूँ पहले. fx is equal to a naught by 2 plus summation n is equal to 1 to infinity an cos nx plus bn sin nx. Suppose I take this one. So what will happen? The first value of a naught I want to calculate. So what I will do, I will take integral minus pi to pi fx dx, and this side it will become minus pi to pi a naught by 2 dx. Correct? And this side integral minus pi to pi cos nx or minus pi to pi sin nx. Both will become 0. So this will become a naught by 2 into this integral will become 2 pi. 2 pi and 2 will cancel. So that's why I took by 2 here for this symmetry, ताकि ये 2 cancel हो जाए. So a naught की जो value आ जाएगी, that will come as 1 by pi minus pi to pi fx dx. So this is the value of a naught. A naught की value मिल गई हमें. We got the value of a naught. And what about the value of an? Again वही करेंगे. इस बार मुझे an को बचाना है. I want the value of an. So what I will do, I will multiply both sides by cos nx. So this side it will become fx cos nx is equal to, so a naught by 2 cos nx. So this term will be gone, and plus an cos square nx and plus bn sin square nx. So such terms will be formed. So if you integrate it, minus pi to pi dx by integration minus pi to pi dx, this term will be
So sin square.
sorry,
Sin square. Sin
oh
and cos.
no, sin nx cos nx, cos nx will be there. So this term will be gone, this term will remain, minus pi to pi dx, and again this term will also be gone, minus pi to pi dx, this term will also be gone. So what will be the value? So the value of an will be equal to 1 by pi integration minus pi to plus pi and this cos square, so this will become fx cos of nx dx. Let us see what will happen to this. This I can write 2 times 0 to pi cos square nx dx, and this will just become 2 times upper limit by 2. So this will cancel. So it will become pi. So you see, because of this symmetry यहाँ पे a naught by 2 लिया गया था कि यहाँ भी 1 by pi आ जाए, यहाँ भी 1 by pi आ जाए. So the formula will become elegant. थोड़ा सिमेट्रिक और अच्छा दिखने लगेगा, बस यही कारण था. तो बहुत ही सिमेट्रिकल है. तो अब अगर मैं सीधा लिखूं bn वाला फॉर्मूला, so bn I can now write directly. In another case, I will multiply both sides by sin nx and then derive. So it will come out to be 1 upon pi integral minus pi to pi fx sin of nx and dx. Fx sin of nx and dx. So a naught, an and bn, all three formulas are ready, and now we can write our function in this form. Please see this. So this was important because every time I solved this in partial differential equation, I actually derived it. मैंने ये नहीं कहा कि मुझे फॉर्मूला याद है, बट अब बिकॉज आप फुरियर सीरीज पढ़ लोगे तो अब आप इसको एज ए फॉर्मूला भी यूज कर सकते हो डायरेक्टली. सो इज देयर एनी कंफ्यूजन?
हेलो सर. सर अगर हम a नॉट बाई 2 कंसीडर नहीं करेंगे तब a नॉट कंसीडर करेंगे 1.2 पाई आएगा इसके यहाँ पे.
हाँ, तो यहाँ पे 1/2 पाई आ जाएगा.
ओके सर.
तो थोड़ा सा सिमेट्रिकल नहीं दिखेगा, बट अगर क्वेश्चन में a0/2 नहीं गिवन है तो तुम्हें वही लेना पड़ेगा ना, जैसा गिवन है वैसा ही लेना पड़ेगा. बट दोनों से सीरीज सेम आएगी. a0 की वैल्यू अलग आएगी, बट पहला टर्म सेम होगा, प्लीज राइट इन बोथ केसेस, मैंने गोला करके बताया भी था आपको, इन बोथ केसेस द फर्स्ट टर्म विल बी सेम। सो इसको भी नोट कर लेना चाहिए ताकि कोई कंफ्यूजन ना रहे आपको। That if your function is like this, an cos nx plus bn sin nx. Suppose this is your series. Then, if this is your series, then you will write a naught is, and the range is minus pi to pi, which I am discussing right now. Then a naught will become 1 by 2 pi minus pi to pi fx dx. An will become 1 by pi minus pi to pi fx cos nx dx, and bn will become 1 by pi minus pi to pi fx sine of nx dx. So this, write this formula also separately so that quick confusion na rahe. And here you can see here 1 by 2 pi, then 1 by pi and 1 by pi will come. Okay, बिकॉज आपने वो उसको बैलेंस करने के लिए a नॉट बाई 2 तो लिया नहीं, तो जो आ रहा है वही आ रहा है, whatever is coming that I have written. So this was the full series which was given. The function is periodic between minus pi to pi, and the same formulas will be applicable if the function is given periodic between 0 to pi also. Because here also, what is the period? Period is 2 pi. Pi minus minus 2 pi. It is like this, that यहाँ minus pi से pi के बीच में अगर periodic है, so the period is 2 pi. And here also, suppose it is periodic between 0 to 2 pi, then also the period is 2 pi. Then also the period is 2 pi. Correct? One thing more I want to tell you, what if, suppose that my period in this case is not 0 to pi, but suppose it is minus L to L or 0 to 2L. So what we will do is, we will just use our unitary method and I will convert the period into the pi scale. So how we will do that? So for 2L, we want to write 2 pi. So now the period is 2L, but we want to write in the scale of 2 pi. So for 1 it will become 2 pi by 2L, and for x we want to write it for x, so it will become 2 pi by 2L into x, which is pi x by L. So the x will be replaced by pi x by L in new formula. Using old formula, we will convert this. So note down this first of all, that x will be converted to pi x by L. Okay, so this is the scaling that I have done. So now let us write the Fourier series in this case. So let me write the Fourier series in this case. This is very, very important because this is general. Minus pi by pi was particular. So fx will be given by a naught by 2 plus summation n is equal to 1 to infinity an cos n pi x by l, because x is replaced by pi x by l, plus bn sin n pi x by l. So this is your new series. So a naught this time will be given by 1 by l integral minus l to l fx dx, and a n will be 1 by l minus l to l fx cos n pi x by l dx, and bn will be equal to, so this is very symmetric once you understand, 1 by l minus l to l and fx sine of n pi x by l and dx. Check this. If you put L is equal to pi, so this will become minus pi to pi and your old formulas will be recovered. You can see by putting L is equal to pi, your old formulas will be recovered. So now this full series formula you know now. So we will take so many examples. Don't worry. L क्या है, कौन सी चीज क्या है, वो सारी चीजें तो एग्जाम्पल से समझानी पड़ेंगी. We will solve so many problems. बट अब इसमें ये है कि क्वेश्चन 5 नंबर का आया और आपको सॉल्व करना है, तो आर कंफर्टेबल इन इंटीग्रल्स रिलेटेड टू साइन एंड कोसाइन, एंड मैनी टाइम्स ये यूज करना पड़ेगा. इंटीग्रल u v1 माइनस u डैश v2 प्लस u डबल डैश v3 dash dash dash. This formula everybody knows. What is v2? It is integral v1. What is v3? It is integral v2. Like that. This formula everybody knows. This you will have to use. Correct?
Yes, sir.
And also many things related to even and odd functions. So because otherwise ye questions they become very cumbersome, very long, and if you use these things quickly, then it becomes very quick to solve. So this I expect that everybody knows. Integral uv, this I will be using very frequently. Okay. And also I must tell you that Fourier series name maybe you learn at graduation level, but our understanding of Fourier series is actually very from the high school, I would say. How? Let me tell you. Maybe the name you were not knowing at that point of time, but it was the Fourier series you will realize. For example, once I write the formula cos of 2x. So this is some function and the formula is 1 by 2 plus 1 by 2 cos of, sorry, cos square x. Cos square x is this. Correct?
Yes, sir.
And if anybody asks you that what is value of a naught here, so it is 1. जो a naught by 2 वाला फॉर्म है वो स्टैंडर्ड फॉर्म है, तो हम वो यूज करेंगे. What is value of a1? 0. What is value of a2? Half. And what is value of a3, a4? All that is 0. And what is value of bn? It is also 0. So for full series, if the function is even, bn should go to 0 because no need of writing the odd coefficients. ये साइन के coefficients हैं तो even function में इसका कोई काम नहीं. And if fx is odd, then an will go to 0. Correct? If fx is odd, then an will go to 0. Similarly, so ये आपने हाई स्कूल में देखा है कि नहीं देखा है? You have seen
Yes.
this, but
Yes, sir.
ये नहीं देखा होगा कि ये Fourier coefficients हैं. These are just Fourier coefficients. So if I write for sine square x, you will realize it is half minus half cos 2x. This is also even function. This is also even function. Having a naught is 1, a1 as 0, so, and a2 as minus 1 by 2, and all bn's is equal to 0. On the similar grounds, I can write on the similar grounds, I can write, I should tell you about some odd function also, like sine cube x. This is odd function. So what will happen to this sine cube x? You remember sine of 3x is equal to 3 sine x minus 4 sine cube x. So the value of sine cube x is given by 3 by 4 sine x minus 1 by 4 sine 3x. So this is also Fourier series having a naught 0, an 0, and bn b1 is 3 by 4, b2 is 0, and b3 is minus 1 by 4. This was odd function. This was odd function. So you can see these are the Fourier coefficients. So in this way, many functions. Can anybody tell me what will be for cos cube x? This will be odd even function. So certainly, if it is even function, bn will be 0. कोई बता सकता है इसका फॉर्मूला क्या होता है? What is cos cube x? बोलो भाई. What is cos 3x? Cos 3x क्या होता है?
4 cos 2x
4 cos 2x minus 3 cos x.
So tell me what is cos cube x? 3 by 4 cos x minus 1 by 4 cos 3x. So what is value of A0, A1, A2 and A3 and other AN0, other A4, A5, 0 and Bn is also 0. Check this.
सर प्लस आएगा माइनस की जगह
by 4 cos 3x.
यहाँ पे
यस सर
तो क्या होता है, फॉर्मूला क्या होता है cos 3x का? हाँ ठीक है,
4 cos की 3x माइनस 3 cos
ठीक है, ठीक है, ओके. So this is Fourier series without writing Fourier series. और ये previous year questions हैं, सोच लो आप. Fourier series without writing Fourier series. Quickly आपने just trigonometric knowledge से ही लिख दिया, हो गया काम खत्म. But ऐसा नहीं होगा. So any question you want to ask up to now? Even and odd function everybody understands?
Understanding.
yes sir
So any question you want to ask up to this? So let me tell you what I meant when I said piecewise periodic. That one thing I should explain. Suppose a function is given like this, suppose, and this is minus pi to pi. So you can see this is a parabolic function. Yes? So P, this is not a periodic function ना, ये तो अगर आगे बढ़ोगे तो ये ऐसे जाएगा. But we make it periodic like this. Suppose it is given in the question itself. This thing is replicating on the both sides like this. So then we can also write the Fourier series. So it was not periodic, but this was piecewise periodic. I mean this piece is repeating. ये बहुत confusion होता है. और suppose दूसरा function भी हो सकता है. Like suppose this thing is repeating. Correct? So suppose this whole thing is repeating in the space. So this is also example of piecewise periodic function. Or you can take any other thing. For example, I can take this. Suppose this thing is repeating. This suppose minus L, this is L, and this whole thing is repeating now. आगे यही repeat करते चले जाओ. इसी तरह से same way like this. So all these are examples of piecewise periodic function. You have to just see which part is repeating, and that will become the period. So this thing will become period. Here this thing will become period. So just see which part is repeating. Clear? So just if I take the simplest function to write the Fourier series, I will have to use the complete cycle. So if you have understood this much, just revise all this, and from tomorrow I will take different type of very good quality questions. And please अभी इसी को repeat कर लो बस. Don't go for too much here and there books and all and all. And Krasik will be the book from which I will be following this chapter. So from the Krasik, okay. But अभी आपके पास ज़्यादा टाइम नहीं है. आप just जो मैं पढ़ा रहा हूँ उस चीज को आप अच्छे से रिवाइज करना. So many good questions I will do in the class and you will understand everything. बस इंटीग्रेशन वाला पार्ट आपको मेहनत करना है so that कि उसमें आप ना फंसे. Okay? Is that clear?
Yes, sir.
yes sir
Okay, then thank you so much.